Welcome, everyone, to the webinar, Agritecture webinar titled Advanced CEA Strategies for Strawberries, Vine Crops, and Greens in Tropical Environments. Thank you very much for joining. My name is Alberto Lopez. I'm Systems Engineer for Agritecture. I've been working for Agritecture for around 7 years. My background is agricultural engineering and biosystems engineering. I worked a lot in climate control strategies, yeah, for greenhouses around the world. My home place is Costa Rica. Again, tropical conditions, so we understand a little bit about the issues here. I'm going to present first a little bit about agritecture for the people who doesn't know the services that we provide. And then I will move with our main speakers today, which is Crable Equipment. Agritecture is the leading advisory and technology firm for CEA in the world. And just to summarize a little bit about our mission and our vision, we focus more into uh, resiliency of agriculture and feasibility as well. We have around 350 projects, more than 350 projects around the world, in 45 different countries. This ranging from yeah, small greenhouses to vertical farms as well. Our services, we provide a lot of services. So we try to connect the entrepreneur, so whoever wants to build these projects, with investors and with suppliers as well. That is our mission, to be in the middle of the industry and connect everyone so that we can grow this industry. We provide services such as concept development, market research, farm design. This is where we join a little bit the entrepreneur with the suppliers, and we do also financial modeling, and also we support the entrepreneur with implementation as well. I want to talk a little bit about today's topic. So what we will cover are mainly the challenges for production in tropical climates and the strategies that make CEA viable in tropical regions. We understand that in CEA means the power to control temperature, humidity, airflow, and this decides as well what can be grown there. We understand also that there's a need for a more efficient and more diverse local production in this part of the world. And that the one of the main, let's say, constraints is the production and capital costs as well. And here I want to present today's speakers, Crable Systems. So they specialize in retractable roof production systems. We have today Richard Bolevre, director of Crable Systems. We have Carlos Ruiz, the director of business development in Latam, and Arturo González Delgado, the manager of business development in Mexico. Again, a little bit about the company. Maybe you guys can also provide a little of information. I know you guys will. Crable Equipment is around a 50-year-old company that is focused in designing and manufacturing retractable cool roof systems. They have presence in around six different continents, but mostly they specialize in the parts that needs cooling, in which cooling is a challenge. They have projects, again, as I said, in six continents, and they range from berries, vegetables, fruiting trees, herbs, and flowers. And now I want to present, or I want to give the floor to Carlos and Richard for the presentation. We will do the presentation in English. However, you can ask the questions in Spanish as well, and we can answer in Spanish. what we want to cover, and well, the agenda for today. We will start with the issues, the primary issues in tropical environments, then the traditional solutions or CEA solutions that we found, the type also, we'll continue with the type of retractable roof systems that Cravo equipment has to offer. And we move a little bit into the case studies, successful case studies in the region. At the end, we will have some time for question and answers. So, Carlos and Richard, take it away.
Great. Thank you very much, Alberto, and thank you for the opportunity to share our experiences. I'm just going to make sure I do the screen sharing correctly. Perfect. All right, just a quick introduction on where we're coming from with these experiences. We've been focusing on automatic retractable roof greenhouses, cooling houses, field covering systems for over 48 years, and have invested in our own R&D facilities in Mexico. Carlos, who's with me here, he actually managed the facilities in Culiacan, Mexico, and Arturo, who's on the call, also managed the demonstration facilities in central Mexico. So the ones in Culiacan was focusing on the vine crops. The ones in central Mexico were focusing on the berry crops. So what we're sharing here is really things we've already experienced through research and development, through success and failures. And so I will take you through that now. So as Alberto said, our focus, our focus is really on the hot climate. So between these two lines here, when you're farther away from the equator, your problem is more about lack of light and lack of heat. And when you're closer to the equator, your problems are different. So quick outline, just a quick summary of the challenges. Other challenges that growers are facing that we have to consider when we're looking at solutions. Just a quick discussion on the conventional houses that are used, and then retractable cooling houses and some focuses on different crops. So basically, if you start with, farmers would never buy any sort of structure if they didn't have climate challenges. And so basically, when you're in the tropics, rain, hail, excessive sun, and hurricanes, cyclones, or typhoons are the major weather challenges. If you're doing vegetables, obviously insects are a major challenge. And this is really, I'll say, some of the really important other factors that you need to think about. We travel around the world. Growers are telling us everywhere the weather's changing and it's getting hotter. So what worked in the past during hot temperatures is not necessarily working anymore because the temperatures are increasing and for longer durations. There's a shortage of experienced growers and labor. Depending on where you are, there can be challenges with the cost or dependability of electricity or water quality or quantity. Soil health could be deteriorating over time. And growers are having to figure out how to produce more kilos per square meter to compensate for rising costs of production. So when we are looking at trying to figure out what the solutions are, what we're really trying to do is combine an understanding of the climate with the plant physiology and also economics. And so building financial models that will start to anticipate how would a retractable solution compare to other solutions from a CapEx, OpEx point of view. So the challenge is, how do you balance managing rain, heat, and insects? And if you look at the typical structures, people will use net houses because they're low cost and they protect against insects. The problem is rain and dew reduces quality and increases disease pressure when the moisture gets inside. They're too hot in the summer. If you get colder temperatures in the winter, growth slows, and the net is susceptible to damage from strong winds, especially as the net ages. One of the things we're seeing as a very strong theme is that growers really need to make sure they can extend their production season as long as possible to supply the retailer as long as possible, but also to try to get those higher prices per kilo during the shoulder seasons. And so typically Net houses are a great way, low-cost way to cover large areas, but you really don't have any climate control. When people want to protect from rain, then they build greenhouses, and the advantage is it protects from rain, works well when you have reasonable temperatures. You can put insect net on, but there's some very serious challenges when you put a greenhouse in a hot climate. It's increasing your temperature and humidity levels, lowers the transpiration rates, which then can cause nutritional deficiencies. And you can actually get higher foliar disease because of the higher humidity, the lack of direct sunlight, wind. Insects can reproduce a lot faster when you're in a greenhouse. And one of the things we saw is when people want to grow in the soil, not everybody has the skill set to grow hydroponically. And oops. And over time, the EC starts to increase. And then all of a sudden, they're running into problems with high EC in the soil. And that's because the plastic kept all the rain from leaching the salts out of the soil. Then you might have to invest in additional cooling equipment, fans, shading systems, mist or fog. And again, plastic roofs are especially prone to damage during strong winds when the plastic ages. So the question is, do you need a complete greenhouse 365 days a year, or do you need a big umbrella when it rains? Because if you're in the tropics, your temperatures are generally not too cold. Your challenges are rain and high sun radiation. And umbrellas, you use them when it's raining or when it's too hot. So I'm just going to show you a couple of videos on two different retractable roof house models. And then we'll have a discussion later on the different crops.
Are you a grower of berries or vine crops like tomatoes, cucumbers, or peppers in hot desert or tropical climates? What if you could combine the strengths of two powerful solutions to protect your crops in a way that is both dependable and cost-effective? Introducing Cravel's powerful combination of the retractable flat roof house with the advanced rain shelter system, Auto Dry. Designed to withstand damaging storms while still making economic sense for growers. Flat roof operates independently from the Auto Dry, allowing you to control temperature, light, and rain levels precisely, all while reducing your investment per hectare by 30 to 40% compared to previous retractable solutions. The flat roof system offers significant advantages. Maximum cooling is provided by its height, standing 6 meters or nearly 20 feet above the ground. It's retractable to optimize light, ventilation, and temperature. It supports heat-sensitive crops with cooling roof coverings or insect netting for vegetables. It's proven to withstand hail and strong winds, with coverings lasting 8 to 12 years. Its design protects the Auto Dry roof from harsh winds and minimizes rain splash, keeping your crop safe. The Auto Dry rain shelter system enhances crop protection by channeling rain to a narrower area, keeping your plants dry, trapping heat during colder conditions to guard against frost and advance harvests, reducing nighttime dew accumulation to prevent disease, and blocking excessive sun radiation on particularly hot days. Together, the flat roof and Auto Dry systems minimize costs for electrical wiring and maintenance, with one motor powering up to 9,000 square meters, using only 3 to 5 kilowatts of electricity per day per hectare. They can operate in winds of 50 to 60 kilometers per hour, offering durable and responsive protection. With the ability to retract over 100 hectares in minutes, Cravel systems have withstood 25 hurricanes, cyclones, and typhoons without sustaining significant damage. Why wait? Manage excessive heat, rain, and winds with Cravel's flat roof and Auto Dry motorized rain shelter system, and be ready for optimal growing conditions, higher yields, and greater control over your crops year-round. Contact us today to learn how Cravel can transform your operation and protect your investment for years to come.
So this product was really developed for locations where the revenue per kilo is lower. And, when selling tomatoes in Europe or in the United States and you get paid high price per kilo, you can invest more. But if you're selling to the local market and you're getting a lower price per kilo, you cannot make the same level of investment. So this was a lower cost, more like an automatic retractable field covering system, so that if you're growing crops and you just need weather protection, this is an example of something that can help you manage both the rain and the heat and the hurricanes. Now, for growers looking for more complete control, there's a different set of house models available.
Gravel's retractable roof greenhouses and cooling houses can help you create an expanded range of climates to grow premium quality plants and produce while lowering your cost of production. There are 3 distinct models, each designed to protect crops from rain using integrated gutter systems. Each model can be equipped with up to 3 layers of retractable roof systems, providing enhanced flexibility and precision in climate control. Meet the A-frame, Gravel's strongest, most prestigious peaked roof house. Designed to withstand hurricanes, snow, and heavy equipment loads, while maintaining an elegant and sophisticated structure that complements any commercial setting. With the widest range of standard sizes and the ability to customize height and load capacities, the A-frame adapts easily to extreme conditions and specific crop requirements. For growers who don't require support for heavy snow or equipment loads, the rafter house offers a lighter, more economical structure without sacrificing durability. Optimized for mild or hot climates, it uses a structure with a post under the peak and the gutter. The rafter must be installed on relatively level land and can be built with either lower-cost exterior cable bracing on the gable ends or roof bracing when land constraints are a factor. If you need to cover large areas at the lowest possible cost, and your land includes uneven or rolling grades, the X-frame is your ideal solution. As Gravel's most affordable peaked roof design, it's built for flexibility and efficiency. With 9.6 meters or 31.5-foot widths, the X-frame uses truss rods, cables, and exterior perimeter bracing to reduce costs. The unique tension truss eliminates the need for custom design and fabrication to handle rolling grades, which can help you avoid expensive grading or the cost of securing grading approvals. The X-frame is especially well suited for orchards and berries, and is strong enough to support hanging vegetable crops. Gravel's peaked retractable roof greenhouses and cooling houses deliver the next level of climate control, creating the ideal growing environment so both your crops and your profits can thrive.
One of the key issues when you're building in the tropics, you might be exposed to hurricanes. And if you're using bank financing, the bank will normally insist on the building being built to a building code that can handle the hurricanes. And so the A-frame house has been designed for up to, I think it's 165 mile an hour, over 200 kilometer per hour winds with the roof and walls closed, all certified by third-party engineers. And so when you're trying to solve problems in the tropics, you do have these weather extremes that don't show up somewhere else. So basically, if you say, okay, the retractable roof house is there to manage sun, heat, wind, rain, and insects, because you can add a layer of insect net underneath. There's a couple key limitations that we've learned through our trials. Number one is it's very difficult to lower nighttime temperatures, and crops like tomatoes and strawberries typically require nighttime temperatures of 22 Celsius. And if you've got nighttime temperatures of 30 degrees, there's really no practical way, unless you're looking at a very expensive semi-closed greenhouse or air conditioning, to get your nighttime temperatures. So when you're trying to think of what you can and cannot do, if your nighttime temps are too high, this is when you want to start to look at higher elevations, so you can get the cooler nighttime temperatures. And then crops like lettuce, of course, they will require water chilling during the summer to keep the temperatures down. So how you achieve the higher profitability depends on what you grow. And I'll just show some quick videos of some of the different crops so you can get an idea of what has already been done. In the Bahamas, Australia, and Jamaica, using NFT or floating raft systems.
So the Oasis Grow House is the first of its kind in the Bahamas. It's a retractable roof cooling house. Now, typically when people think of plants growing within a structure, they may automatically say greenhouse. But here in the Bahamas, we really don't have a need for greenhouses, because greenhouses are meant to trap heat, keep warmth, and amplify sunlight. But here in the Bahamas, we have plenty of both. We actually need to protect the plants from too much light and too much heat. So the retractable roof cooling house does just that. When it's too hot and the sun has been out and intense for too long, we close the shade and the plants get a little reprieve. If it's raining, the roof closes and we protect them from rains. So the importance of this structure is that it provides a unique growing environment, optimizing the climate for the plants whatever we want them to experience.
This video is from a herb grower in Australia near Brisbane that I took just in February of this year.
Hey everybody, it's February the 18th, 2026, and we are at Riverdale Herbs, about 1 hour outside of Brisbane. And it is now February the 18th, and outside we have an air temperature of 36 Celsius, and the relative humidity is 46%, and it's only 11:30 in the morning, so it's going to be another hot one. In this particular house, this facility was constructed about 7 or 8 years ago. It has a retractable greenhouse roof on top and a retractable interior cooling curtain using the white Klima open fabric. Since we're in a more tropical, humid place, we want a covering that will provide shade but also give us some ventilation through it. When this facility was installed, they installed a high pressure fogging system and horizontal airflow fans. And so I was talking with the owners today about their experiences of the high pressure fog and the horizontal airflow. Because we're in a very humid location, the fog system is not being used that frequently, but the horizontal airflow fans have proven to be very, very beneficial. If they have stale air inside during the daytime, you can see that the retractable shading cooling curtain is partway gapped right now to get some airflow. But one of the biggest benefits they spoke about, which I found very interesting, was because the night times can be very hot here, they would have the roofs retracted at night, the shade curtain retracted at night to try to cool the crop down, because the night times can get very hot up here in Queensland. And so what they found is when everything's retracted to help cool the plants down, they were turning on the horizontal airflow fans at night just to create a constant breeze in here, which is also helping to cool the plants down, but also it was preventing some of the dew accumulation. They could close the roof 95% at 4 o'clock in the morning to try to keep the dew off, but they found that just with the horizontal airflow fans running, they were able to help create a better environment when growing these crops through the summer. They are growing coriander, watercress, and basil, and the winter time is quite conducive for growing here, but this facility was really designed to help maximize production through the summer so that they could produce 12 months per year.
I took this video in Delhi to show you the difference in leaf development between a retractable roof where the plants are getting exposure to direct sunlight for part of the day versus a pot and fan house where the plants are never exposed to any outdoor conditions.
It is May the 5th, 2022, and we are in Delhi, India at the KBC Cravo A-frame retractable roof greenhouse with a retractable cooling curtain inside. And what I'm going to do is show you a comparison in the lettuce development between a conventional pad and fan greenhouse and the retractable roof. So last week the air temperatures here were 41 to 42 degrees. Relative humidity was 20 to 25%. So we're dealing with the hot summer conditions. And so here in the retractable roof, we only have a cooling curtain and a low pressure misting system. There is no fans anywhere operating in the house. So if we look at the difference in the plant development, so this plant here was grown in the retractable roof, and we can see that the size of the leaves are large and the color is darker green. And the leaves are quite firm. You can hear they were crunchy when I started to bend them. Now in the pad and fan cooled house, we can see this plant is the same age. And so there's, first of all, less leaf development because this plant here had less sunlight because the plastic roof is blocking a lot of the sunlight, and they need to be pulling the shade frequently in order to help cool the greenhouse. The second thing though is the pad and fan cooling system is injecting a lot of humidity into the house, which is causing a low transpiration rate. So we can see we have less quantity of leaves, the color is lighter, and the leaves are thinner, and that's going to contribute to a reduction in quality from the part of the consumer and also a reduction in shelf life. Now, given that both these plants are the same age, the other difference is in terms of cost of production and sustainability. The plants grown in the retractable roof are using 95% less electricity for cooling than the pad and fan, and we're using probably 95% less water for cooling because these misters here are only operating for several hours a day, and they're pulsing for say 10 seconds every 5 or 10 minutes to help give us a evaporative cooling and to raise the humidity. So we're using more electricity, more water, but more importantly, we're getting less leaves, thinner leaves, and a shorter shelf life. So this is May the 5th, 2022 in Delhi. And so for people that are growing lettuces in the hot climates, this is the difference between a conventional pad and fan cooled poly house and a retractable roof.
Per day per hectare, and the cooling is being done using the retractable roof by closing it part way, or basically shading and blocking the sun, but leaving a gap for ventilation and air exchange. So they've got a very low cost of production here and a very environmentally friendly production system because they're not using, they're using 95% less water and 95% less electricity than a pad and fan house. Now, growers are always afraid of if you open the roof and you don't have insect net, all the insects are going to come in. There's some very interesting things we've learned. I mean, first of all, you've got varieties that have different levels of resistance. And we grew tomatoes without insect net. And we could see a dramatic change in the structure of the leaves. And actually, there is a doctor, Dr. Jorge Berni from Mexico, did his PhD thesis studying the change in leaf development between a retractable roof and a stationary roof. And he was able to see the significant changes in the development because we saw less insect damage, less insect reproduction in tomatoes in a retractable roof house, even if there's no insect net, simply because the plants are so strong and healthy that the insects are choosing not to reproduce. And it's kind of counterintuitive, but until you've seen a plant development in a retractable roof, you don't really think that the structure of the plant has changed. This video was taken in Turkey, and I want just to listen closely to when I bend the leaves. So when your leaves are that hard, they are not a good food source for the babies. And so the insects tend not to reproduce on strong, healthy plants. Instead, they choose weaker plants where the babies have an easier time feeding off the leaves. And so when you're in a conventional greenhouse and you do see insects come in, the reproduction rate tends to increase very rapidly simply because there's a very good food source there. And so if you're growing in the tropics, if you can find varieties that are very good, have a good resistance to virus, it may be worthwhile trying either no insect net or retractable insect net so that you have the better ability to manage that heat and humidity. Because the insect net, while it does give you protection from insects, it's also blocking light and trapping humidity. As I mentioned earlier, we had an R&D demonstration house in central Mexico, and we had a simple retractable roof. And for 4 years, we were trying to grow the strawberries through an extended season. And then we put a high pressure fog system in, and it was.
Would you like to produce this quality strawberry when it is 35 Celsius outside with a 15% relative humidity? Would you like to extend your winter production season from October until June, using the least amount of water and electricity? It is April the 19th, 2024, and these strawberries were just harvested today inside our retractable cooling house at Irapuato, Mexico. Irapuato is located at 1,700-meter elevation and at a latitude of 20 degrees north. These strawberry plants were transplanted in July and August of 2023, with the first harvest starting in October. These strawberry plants are grown outside in the morning, taking advantage of the high light and cooler temperatures. But around 9:30 a.m., when the leaf temperature exceeds 26 Celsius, the white cooling roof will be closed 92% to leave an 8% opening for ventilation. 3 weeks ago, we installed a VFRA high-pressure fog system to help cool and humidify without wetting the plants. Previously, we used a low-pressure mist system, but it was unable to increase the relative humidity inside sufficiently without wetting the plants. So on April 19th at 2 o'clock in the afternoon, the air temperature outside is 35 Celsius, which is today's maximum temperature. The lowest temperature tonight will be 15 Celsius. The relative humidity right now outside is 15%. The sun radiation is very strong at this high elevation, making our black plate temperature outside on the weather station read 42.3 Celsius. When we close the cooling roof and the relative humidity inside drops below 30%, the VFRA high-pressure fog system is activated with 25-second pulses at 30-second intervals. The combination of the cooling roof and fog reduces the air temperature from 35 down to 32 Celsius and increases the relative humidity from 15% to 51%, and most importantly, reduced the leaf temperature in the direct sunlight from 35 Celsius down to 28 Celsius. These changes dramatically reduce the transpiration rates and prevents excessive water stress, prevents sunburn of the fruit, and virtually eliminates the attack of red spider. Around 5 p.m. when heat levels are lower outside, the cooling roof is then retracted to allow the plants to take advantage of the higher light levels and transpiration rates to increase fruit size and firmness. The roof stays retracted all night, helping to cool the fruit to increase Brix levels.
Over the last 5 years at our strawberry demo house, we have proven that we can transplant during the hot summer months of July and August, start the first harvest in October and produce good quality fruit until mid or late June, produce 70 to 120 tons per hectare of number one quality fruit using good varieties and good quality young plants, use 80% fewer applications of agrochemicals, and use 50% more organic sprays compared to tunnel production, and produce using minimal electricity year-round and only using water for cooling during the hot, dry conditions. If you find these videos interesting, uh, you will find a lot of information on the website. If you go for growing plants, you'll see the videos on all of the different retractable field covering systems. If you go to the cooling house and greenhouses, you'll see the videos on the different greenhouse structures. But the section that I'm most happy about is actually the grower resources, because you can go in here and learn about all of the different experiences that we've had and see a series of videos from parts around the world and different PowerPoint presentations or webinars that we've done. And so if you want to go deeper into learning some of the different crops, simply go to the grower resources page and you will get more information. So that is the end of the formal presentation. And so I'm going to stop sharing here and I will pass it over to Alberto to take over here with the questions.
Perfect. Thank you very much, Richard. Really, really interesting. Really interesting how yeah, these retractable roof systems manage the climate inside. Yeah, one of the concerns that when I started seeing the system was the insect, right? How do you control insects and all this type of thing? And you touched that there. Do you think, or can you elaborate a little bit about, let's say, the importance of the health of the plant health in creating, let's say, a non-hospitable environment for the insects?
Yeah, so let's start with plants develop according to the environment they're in. So if they're exposed to direct sunlight and they have higher transpiration causes them to develop thicker wax cuticles. Thicker wax cuticles form a natural barrier against transpiration, but they're also a barrier to insects. And if you just look, if you walk through a greenhouse and you look, where is the highest insect pressure? On the strong, healthy plants or on the weakest plant? It's always the sick plant. And so right there, everyone can prove to themselves that the plant health is there's a direct cause-effect relationship between plant health and insect behavior. And so, Carlos is an entomologist, so he's been a tremendous help in us trying to understand this. And if you think that insects are choosing where to reproduce, right? They could lay their egg on a rock, on a steel post, on a strong, healthy plant, or on a weak plant. You always see the insects gathering on the weakest plants. So my starting point is, are you afraid of insects or are you afraid of weak plants? And so how do you create the strongest plant? Well, the strongest plant is an outdoor plant, essentially, because it's had exposure to sun, wind, and changes in humidity and transpiration. And so the development of the plant has a direct bearing on the desire of the insects to reproduce on those plants. So if you're in a cold climate, you don't have a choice of opening a roof. And, even if you have insect net underneath the retractable roof, the insect net is allowing direct sunlight through all the openings in the net. And so if I can get direct ultraviolet radiation, direct infrared radiation on the leaf, the plant's going to develop in response to that climate. And so when you focus on creating the right environment for the plant, you're simultaneously focusing on changing the development of the plant to minimize the insect's desire to reproduce on those plants. Now, that's different than if you had thrip attacking a flower, right? This is about sucking insects. So if you have risk of thrip damage or Carlos, what's the other one? Pepper weevil? You know, those
Pepper
things.
weevil or red spider.
Yeah, those things you just pepper weevil, you have to screen,
Yes.
right? There's no option on that. So the starting point is when you compare a conventional greenhouse that's naturally ventilated, right? You got butterfly vents at the top. And so you might have a 1 meter or 1.5 meter piece of insect net vertical for air to escape. And so if I've got a 12-meter wide greenhouse and I've only got a 1 or 2 meter wide vent with insect net, there's very little air exchange. And if we put a layer of insect net across the entire growing area, I'm increasing the amount of ventilation and light. And so we start with, if you go to Mexico or India or places like that, they do a lot with net houses. Yeah, they can grow a decent crop with net houses. The problem is they cannot deal with rain and they cannot deal with cold or too much heat. So the moment you put a retractable roof in combination with a layer of insect net, you're combining the technology of net houses with retractable roof for climate control. And so that's what we always look at, what's being done around the world and how can we combine technologies to do something that's, you cannot do otherwise without a retractable roof.
This is quite interesting now that you're talking about integration of your system with other systems. I have seen techniques, let's say when there are extreme climates, extreme temperatures, let's say complementing or supporting, let's say air climate control with root climate control. Do you have experiences with this in which they use, let's say, a chiller or cool water to irrigate to manage the let's say the leaf temperature or the plant temperature?
Now, the only time I've seen cooling is more chilling the water on lettuce type crops. You're trying to manage root temperature there. So when you have a retractable roof, a retractable cooling curtain, and high pressure fog, you kind of have all of the technologies there because what you're trying to do, excuse me, you want the plants to get maximum sunlight at 8 o'clock in the morning, right? So you don't need a roof, you don't need a shade at 8 o'clock. Then by 10 o'clock, you may need to reduce the sun radiation. So you close the shade and cooling curtain and the greenhouse is retracted. And see, this is one of the critical differences between a conventional greenhouse and a retractable. And that is a conventional greenhouse will always increase your temperature in the daytime if it's sunny. If it's 30 degrees outside, without a cooling system inside, it's going to be 45. Right? So a greenhouse actually makes it hotter on a sunny day. If I retract the plastic roof, if the outside temperature is 30, the inside temperature is 30. If I close the shade curtain, I'm going to reduce the sun radiation on the plants to lower leaf time. If I activate the high pressure fog system, I'm now getting evaporative cooling to lower the air temperature and increase the relative humidity so the plant's not transpiring too much. So we tend not to focus as much on air temperature. We tend to focus more on leaf temperature. And you'll notice in the videos, we were using infrared thermometers to actually measure what's happening with the leaf, because that's the best indicator of whether you should be opening and closing a roof or shade, because you're actually trying to manage plant temperature, not air temperature.
Understood. Understood. Very interesting. I wanted to ask a little bit. Well, I think Carlos answered all the questions. I think there's an open question here by Samuel. How to protect
Yes.
crops from the cold temperature below zero in a retractable roof system. Does this system work for below zero temperatures?
Yeah, I mean, it's essentially a poly roof. So if you close the roof at night, it's going to act similar to a poly covered greenhouse with a single layer of plastic. And so um, the first thing is you look at a Cravo solution where you have really cold temperatures for extended periods of time. So if you have a cold front blow in for a couple days, that's fine. But you would never use a Cravo solution where it's 0 degrees for 4 months straight,
Mhm.
right? This is where we're focusing on the tropical desert climate zones where your temperatures might be cool at night, but not cold during the daytime for extended periods.
Got it. Understood. I have another question, and I think it's more about trying to explain or trying to go back to how the retractable roof is controlled, right? So what is the control? And I guess what you said was something about trying to measure plant temperature, right? So here, what we're trying to control, I assume, is more transpiration of the plant, right? How we manage transpiration of the plant, and that's how the control system works. That's my assumption, I guess.
Well, okay, so let's start with um, you've got a weather station outside. The weather station is telling you if it's raining, the roof would close. It's telling you if it's too windy, the roof would close. It's telling if it's cold outside, the roof would close. It's telling you if it's too hot outside, the roof or the shade would close. And so we're really using the outdoor weather station as the primary driver of the roof position. Um, you will know if you're controlling it correctly by actually measuring the leaf temperature. And so think of there's a difference between a control point and feedback point. So I might be using the weather station to control the roof and the shade curtain. I will have an indoor air temperature and humidity sensor that tells me what's going on. But if I really want to know if I'm doing it right, I want to measure leaf temperature. So if you had an infrared camera, if you're trying to do it the best thing you can, you put an infrared camera on as the feedback mechanism. It's not the control, it's the feedback. It's telling you, uh, think of it as an alarm setting. If the leaf temperature goes over 32 degrees for 5 minutes, you're at risk of getting tip burn on your lettuce, as an example. So it's the right feedback. When Carlos and Arturo are working with our customers, because we have a grower success program where when someone buys a Cravo, we will work with their grower to help them get used to the logic and the thinking of a retractable roof. And basically, you can say if the leaf temperature goes above 31 degrees, you need to take action because transpiration will become excessive if the leaf temperature gets over 31. It might be 28 for a different crop, but it's kind of in that 28 to 31 degrees is, if I got an outside temperature of 15 degrees, I want more sun, I want more heat, I want more transpiration on the plant because I want to push it. I'm trying to get more photosynthesis. And if I can take a roof away, I get significantly more light on the plant. I dry off the leaves. So when people are worried about foliar disease, what is the best organic fungicide?
Don't.
The sun. Get the sun on the leaves, it'll be dry. And the UV sterilizes and kills the spores. So, we don't see major issues with foliar disease, even in tropical places, because we use the sun as part of the strategy for managing leaf wetness and increasing cuticle thickness.
Understood. And then if, let's say, for some or in the cases in which we get, let's say, pests or diseases inside, what are the, let's say, further methods of control that are typically used in these greenhouses?
I will let Carlos. Carlos can talk about his experiences and strategies on pest management.
Yes, it's sure it's more easy to management the disease and insect problem inside the crowd house because the plant already have the natural defense very active because we never running the plant over the optimal rate of temperature and humidity. That means the management of the insect control uh, after with the big defense in the laterals, because we have, for example, the flat roof model is 6 meters tall defense to stop the entrance of the tricks, for example. It's more easy to management inside with the organic protocols. And also clients, we support them and the grower support team. They use more organic protocols and they use the chemical as the last tool to reduce the population of some pests like thrips or whitefly or some other like spider. And for diseases, the cycle of life of disease is a triangle. Triangle life is the host, the pathogen, and the climate. At the moment you close you broke the climate, is no any infection uh, can forward. No?
Okay, so the strategy here at Cravo is to control the environment. That's the thing. We forget about controlling the spores and we forget about controlling the, let's say, or the hospitable plant, right? So the sick plant, which makes a lot of sense, right?
Yes,
Uh,
here's one question for Mohammed. He's asking about least temperatures can rise to the different reason. How about the light level or DLE for the crop? Yes, we measure the light level with the through the white plastic, the cooling roof, and over we provide more than 600 kilowatts light with the screen closed through all the plastic. We provide 45 shades, but also more than 600 kilowatt lights. That means the photosynthesis needs light. We never drop to have any problem. And that's happened within midday and mid-afternoon, like 4 or 5 hours in a day. The rest of the day is completely open and they receive all the light level and the ventilation and those good benefits.
okay, I think that was the last. I have one last question for you guys
Okay.
before signing off. It's more about research and development. So you guys developed this technology, you guys developed this control system. What's next for Cravo?
Um,
What are you guys working on?
New
uh,
models.
well, yeah, the flat roof and auto dry are models that we developed specifically to help people in the developing countries where they don't have the capital or they cannot make the big investments, um, uh, like people in developed countries. And so uh, the auto dry is more of a low cost rain shelter system that could be used for um, blueberries, cherries, strawberries, crops that grow outside, but they need protection. So, not every grower is growing tomatoes, as an example. And so, what's the solution? How do you get people to grow some of the other crops that are really critical? Um, I want to show you. Um, I'm going to show you one picture before we sign off here because this is the picture that changed the belief in what we're doing here. So I'm going to share my screen again here. So this is a book I wrote on the 35 years of experience growing in retractable roofs. And it was all the things I've learned on this journey. And it goes through the plant physiology and the greenhouse design and all that. But I'm going to show you a picture from the from our R&D center that kind of changed everything for us. So back in 2008, we took a DeRuyter 2180 tomato, Roma tomato. We planted it in an open field under stationary insect net and under a retractable cooling roof. Same farm, same water supply, same soil, all within 50 meters apart. 3 months later, we took one plant from each environment. This one is from the open field. This one's from the net house, and this one's from the retractable roof. So when you look at, it's the same genetics, but this is how changing the environment changed the plant development. And so if you look at the one from the net house, you can see there's foliar disease. There's not as much fruit development, but there's a lot of plant canopy. So the low transpiration under the insect net caused the plant to have a lower transpiration, a lower level of water stress, and that caused the plant to grow vegetatively. And growers don't get paid for leaves. And simply by opening and closing the roof and changing the light, the transpiration, and the water stress, we achieve the optimal balance between leaves and fruit. We got more fruit, bigger fruit, and we're going to the market earlier. And so, you know, the industry tries to focus a lot on genetics, but when you're in a tropical place, you've got different challenges, but also different opportunities to manipulate the climate to achieve superior results. And so, you know, everything we're sharing today is based on us, on you know, over 40 years of doing this ourselves, doing the research, working with growers, documenting it to try to, really revolutionize and help growers in those tropical desert climates solve their climate problems. Because what the industry was doing is basically taking technology from Holland or wherever that was designed for cold climates and trying to sell it into the warm climates. I mean, growers need a solution. So they're looking for a solution. The question is, what is the right solution? And so just like I'm saying very clearly, Cravo is not the right solution for a cold climate if you're trying to grow during the cold time of the year. But if you're in the tropics, you go, I need to design something that's dealing with high sun radiation, high humidity, potential hurricane storms. And I may not get as much a high price per kilo. My management, the people are not as skilled as potentially they are in the north. So I need to have simpler approaches that are easier to manage. And so that's where our focus really is, how to bring technology that's suitable for these hot climates that recognize the challenges and the constraints of those climates.
Perfect. No, and then it also shows the way you share information right in the website. You have a really nice portal for the grower, and then just to inform. So I don't know if that book is in the website, but I
It
have seen
is,
a lot.
it is,
Okay, so
it
this
is, yeah.
book and many other resources, you should check it out because it's quite interesting and it's quite full of information, of useful information, and how this system works. Well,
Yeah.
I want to thank you guys. Thank you, Richard. Thank you, Carlos, for participating. It was really, really nice the information that we received, and I hope, yeah, the attendees take some of this information just to understand that there are solutions for hot climates and tropical climates from the CEA perspective. I want also to thank Nico Simos from Agritecture for helping us with all the webinar as well. And yeah, again, just big thanks to everyone who participated.
And we'll
Yes,
see you in Amsterdam next week.
yes.
See you in Amsterdam.
Thank you, Alberto. Thank you, Nico.
Yeah, thank you, Nico and Alberto.
Gracias, gracias, Richard. Gracias, Arturo.
Bye. Bye,
Bye.
Arturo.
Gracias.